Hi, everybody. This is the Kubernetes Workgroup Device Management meeting for May 12th, and we can get started. I'll share the agenda. Okay. Yeah, so first item, talking about different attributes, in particular on CPU here, but I think there's also been a discussion on Slack regarding this. So I guess I'll just open the floor to that discussion. I'll stop sharing. And I know I see John Hull here. I know he started that discussion. So if you want to, since Alay's not here, if you want to jump in with that, John.
Hey, can you guys hear me?
Yes.
Oh,
We can't see you, but we can hear you.
wow, my camera's not coming up anyway. But yeah, I mean, I think a lot of it's in the kind of the Slack discussion. Just PCI root, as far as I think it's a really good attribute and it helps a lot. But I think it's kind of incomplete as far as topology goes. I suggested NumaNode. I know a lot of other people have as well, but I'm open to other options. But I need to be able to, like I said, the thing I want to be able to do a match attribute to be able to get CPU, memory, kind of NIC, and GPU alignment. Be able to create pods or VMs based on that. PCI root based on a lot of different hardware out there and configurations. That doesn't always generate matches. So looking for other options to be able to do that. So NumaNode was my suggestion. So I think the discussion was good. I'm not sure what the next steps are to kind of drive towards an answer or something, but looking forward to keep pushing that forward.
Yeah, I think that. Well, go ahead, Antonio.
The thing is that I think that is the no thing is that we have a well-defined, at least well-defined in the kernel file system number, and I think that the ask is to expose that. And the problem is that, as Sasha explained in the thread, is that some hardware vendors indicate that what it means, it doesn't reflect the hardware correctly in some platforms. But for our use cases, I think that the benefit of at least having a common interface, if it's well defined and everybody has the same meaning for the interface, at least allows us to unblock the PCI memory CPU thing that based on when I talked with Praveen, and I think Francesco commented this morning in the chat, it's a good thing. Despite it's not correct, I think that it's incorrect for everybody, because if it's in the kernel and this kernel is exposed in that way, it's consistent. So I think that at least we should, I don't know, come with some agreement. If it's not that, at least have an alternative, but have a path forward, because otherwise we are never going to be perfect, and things keep moving, and we need drivers to start using it.
Yeah, I agree. Let's not like block just because it's not perfect. Like it might work in enough use cases that it's useful. Um, so I think the last time did we just create a KK issue to converge on the agreement about that, or did we have to like?
The big discussion was in the Garaf when Garaf opened a standardization of device attributes. The original proposal, I think, that was to have PCI root and
Yeah.
NUMA node, and then it's when the NUMA node discussion came
Okay.
pop up, and we decided, okay, this is very complex. PCI root is less ambiguous. Let's just get the PCI. That's my memory on the discussion. So the thread is in the pull request from Garaf, and I can link it here in the chat.
Yeah, I think there is an open pull request against our staging report to extract the NUMA node information. And I think that's the right approach, that we provide an implementation that can consistently collect that information on a Linux system together with a full specification of what that field means. And that specification, yeah, we don't have a good place for it. The PCI root was added in the structured parameters aka dynamic resource allocation cap document. So there is a list of that standardized attributes, but I'm not sure whether that's the best place for it.
No, I think there's a place where like well-known names are recorded.
Yeah, and we as part of that discussion, we said that someone should create a document page update for that well-known names, and that got stuck because the whole page needs to be restructured, and I think that never happened.
Okay. So I suggest we start with a KK issue that's defined the NUMA node attribute, and if other people think like Signode or somebody thinks we need a cap around this, I don't want to do caps for every attribute. That sounds insane, and there's no feature gate for it or anything. So because it's implemented in drivers, like I would rather just do a KK issue and see if that's acceptable to people.
One comment about the cap. So the cap process in SIG testing, another thing is we use we just explain to SIG release is just for documenting and it's not to follow the entire process. As there is no life cycle, there are not feature gates, but we just want to have this as a recorded artifact. So that may also be another possibility.
We could do a lightweight cap that like doesn't go through all the same process. Yeah. We have had caps like that that change policy or things like that. So that's a possibility too, if we think that's going to get better discussion or needs that. So I'm open to either. I'm just trying to figure out, like, I think John's question, what's the path forward? Like, what's the easiest path forward? So I put in the agenda document one other thing I'd like folks, since there's some like renewed interest in this area. We talked probably a year ago about like the way Slurm works isn't with this sort of match attribute type of thing. It's through CPU adjacency. So basically, instead of each device publishing information about itself and trying to model the internals of the node, each device just publishes a bit mask of the CPUs it considers, quote, adjacent. And then the CPU bit mask becomes the coordination point, right? Like for us, we have PCI root as a coordination point for some devices, and now we're talking NUMA node as a coordination point. And this just becomes like CPU information. And so you basically get everybody's published a bit mask, and then you can do bitwise operations to get best alignment possible. So I'd love to gather folks' thoughts. There's an enhancement issue for it. The idea would be that there would be a library to generate this bitmap, and I think it's already available. And so the device vendors then would publish that bit mask. We would have to change. You can't use match attributes for it because it's not just an equality; it's a bitwise operation. So it would be something special where we could, first of all, without even necessarily user doing anything, we could best effort align along those things, and then we could add a field that says basically, hey, don't schedule unless you get alignment across all these devices or these requests. So anyway, there's an issue. I put it in the agenda doc, and I'd love comments on that. I don't think it has to stop this process because they can be two different ways of doing it. But if there seems to be value in that, I'd love to move that forward. All right. Uh, all right. Yeah, we could do lightweight cap. I'm fine with that. At least it gets the common documentation, whereas a Kubernetes issue would be lost. Um, okay. Any other comments on that, or shall we move on to Ashvin? Let me see. I'll share this again. So next we have where's the link here? Context lock effective capacity.
Yeah, I can share my screen and I can talk about it as well.
Okay. Yeah, let me give you permissions. There you go.
Okay, let me share my screen. Okay, so this is to account for the use cases where the total consumable capacity is not a static property. And this builds on top of the sharing affinity, which I presented like a couple of meetings back. Um, and in our case, like SmartNIC, since we dynamically choose the subnet which gets associated with a NIC, we don't know what's going to be the total consumable capacity for that NIC. So we are looking at how can we change that total capacity based on the mode that the device is operating in. And we don't want the claims to basically come up with a random capacity value. The mapping can still come from the driver. The driver can still say, this is the mapping of uh, the mode and the effective capacity envelope. And the claim can just say, hey, I'm operating in this mode. This is my mode affinity. And we will have the corresponding capacity value that gets chosen instead of some static value. And yeah, this is to make sure that like we don't again suffer from the informal consistency gap where even though we said that because of this particular mode, the capacity now has reduced, uh, but the over provisioning can still happen if we don't let the scheduler know that the effective capacity envelope has now reduced or changed from the static consumable capacity, which was advertised in the beginning.
Okay, so uh, so this builds on top of the sharing affinity. Okay, you're okay. So
Y-
keep
Yeah.
going.
So
Yeah.
yeah, basically this builds on top of the sharing affinity. So with the capacity, I'm saying that the heavy lifting of the affinity matching and the basically locking off based on the context can still be handled by the affinity sharing. Um, the additional thing here is it will also basically say, and I mean, the if sharing capacity, sorry, the affinity is still under review, and thanks, Patrick, for active review on it. So some of these things will change based on how that review goes. But basically, what I'm saying is the driver still manages the capacity mapping. It can still say, hey, this is the mapping of the subnet. If it's restricted, the capacity is 8. if it's open 12 and default is 16. And so the driver controls this. The claim just says that, hey, I'm operating in a restricted mode. And the first claim that uses this device sets the capacity. And
You're tying capacity to the mode that you get switched into.
yeah, yeah. And so I'm simplifying this in terms of we are not recalculating capacity for every claim because the affinity of the mode gets locked on the first claim. The
Right.
capacity also gets locked on the first claim. It's just that, uh, um, yeah, based on the subnet, we will now know that, hey, the capacity has reduced. Or in some cases, let's say the FPGA, if the thermal mode is something different, then again, the capacity decreases or changes.
So that makes sense to me. I can see, are there other things dependent on this mode, right? Are there attributes? Is it just capacity? And I start to wonder if there's a different way, if we're squeezing a category of use cases into the existing flow, or if we need a different flow. So one of the other caps we're looking at is this we call consumes from, and it makes it a two-stage flow where you have a claim that specifies a set of resources, and once that's allocated, you have subsequent claims which draw down on that. In that sense, it's similar in that you have a claim that does a mode switch and sort of sets a ground state, and then you have subsequent claims which utilize or draw down on that ground state. I wonder if this is just like a different provisioning flow and allocation flow that we're missing, and we're like kind of coming at it at multiple angles, and there's a kind of a better solution for all of these things together.
Okay.
Yeah,
Yeah,
my
I'll take a look at that.
yeah.
Yeah, go ahead, Patrick.
In the DRA sharing affinity cap, you said that the number of modes is too large to use some of our other existing mechanisms. And for an FPGA bitstream, I can see why that's the case. You basically have a potential unlimited number of bit streams that could be configured for an FPGA. So you can't make statements, or you can't predefine all the different devices depending with their corresponding configuration. But now in this proposal here, you do exactly that. You say, okay, we have a fixed number of modes that are chosen by the configuration, and for those cases, we specify capacity. It feels like that's falling more under the traditional partitionable devices or something where each device has its own capacity that gets consumed and they are mutually exclusive.
Right. So each mode would be a separate device, is kind of what you're saying, which probably that's probably something you considered, Ashwin, in your earlier analysis.
Yeah, because I thought partitionable devices is still the case where we know the capacity up front, right?
Yes.
It's
Yeah,
just
but
Here you're publishing it up front too.
yeah, that's no difference.
Yeah, so here we are saying, yeah, so for different modes, there is a different capacity, and we choose a mode dynamically, and that sets the capacity.
Right, but you had to enumerate the modes and the capacity mapping.
Yeah.
And you could enumerate that in your map, or you could enumerate that in separate partitions of a partitional device map.
I see.
There's another concept like we've been circling around for like over a year. And you see some of it in binding conditions. You see like where we have this idea of like provisionable. Like it's again, it gets back to a different life cycle. I think we're talking about a different life cycle than we've modeled so far. And I wonder if we can capture like this provisioning. Provisioning is one life cycle, right? Where like you have a shape and then you instantiate that shape. You can't enumerate all the possible configuration states of that shape. So you need to do it. But what the scheduler needs to know and the autoscaler needs to know is like kind of like how many of those shapes I can create at any given time and how to calculate without having to go back through that that external call cycle, like with the what you call the inconsistency gap or consistency gap. Like it needs the rules to calculate and iterate and simulate multiple allocations. In particular, the autoscalers need this, but also like pod group scheduling needs this. And so I don't know. I'm just I have a sense that we're trying to squeeze a 2-stage life cycle into a 1-stage process, and we probably need to create a way to have a 2-stage life cycle, and we might simplify a lot of these use cases.
Got it. Okay. Okay. So I'll take a look at that consumes from as well. I did
Yeah,
check.
and I'm not saying we can solve all these things with one cap, but like I just want to make sure that there's not some deeper change we can make that would simplify all of these different patterns.
Okay. Okay.
And I'll think about it too, or anybody. We're all welcome to think about it. But yes, I'd love your input. Yeah.
All right. Thank you.
Yeah. So I guess the short answer is like, in some sense, this sounds reasonable. I think Patrick's point is a really good one. If we're going to enumerate the mappings, aren't we just enumerate? Isn't it the same as enumerating partitionable devices? Is there some change we can make there that would make it usable for you in your different use cases? Or alternatively, is there some different state machine where an allocation of one claim happens and then allocation maybe of separate claims to record that are linked to that? That's kind of what we also talked like a long time ago about, this idea of linked claims, which was vaguely defined, but the consumes from is one way of doing linking. The shared, well, yeah, that's one way of doing linking. There may be others. So not much of an answer for you, but at first blush, this doesn't look, insane, but it looks like there might be a way to simplify all of these things.
Okay. All right. Yeah. Yeah. Thanks.
Cool. Awesome. Thank you. I think that's our last item. So if nobody has additional comments on this or previous topic, then we should probably just wrap it up.
Hey, John, quick question. Back to the
Yep.
first topic. I guess who's opening the lightweight cap? Do I need to do that, or is somebody else doing that? Who needs to do that?
Whoever wants to do it. You're if you're interested, go for it.
All right, I guess I'll do it then.
Yeah, that'd be awesome. And if there's any other low hanging attributes, we can include them in the same lightweight cap.
Yeah, thanks.
Yeah. All right. Thank you, everybody. Have a great rest of your day.
Thank you.